Hello.
Hello, this is Nansu from UCSD.
Hi, Nansu. Hello.
Hi, Anna. This is Nina.
Hi, Nina. How's Elena doing now?
Well, I think she's better, but the doctor said that she has parasites, so she needs to be on some medication.
Oh, okay. All right, we'll talk later then.
Okay, thanks.
Yeah, no, this is Ram and all of us here.
Hi, Ram. So I see you're the presenter now, right?
I think so.
Okay. So once we have a couple of initial items to go through, just
Okay.
very briefly, and then you can take over, the presentation. You can have presentation controls after that. You should be able to just use it.
Okay.
Hello.
Hello.
I know this is Ron.
Hi, Ron. So we just wait for a couple more minutes. I think Huash will probably come in soon.
Hi, this is Wei.
Okay.
Hey,
We just wait for a couple more minutes for Jeff and Hua to join the call, and then we can start. Be another 2 minutes or so. We're just waiting for Jeff to call in.
Okay.
For another minute or so, and then we'll start. Okay, I think we should get started. Jeff will probably call in between. Just to get started in the room here, I have Ergin, Divakar, Yuling, Shaoling, Todd, and Hua. Trevor is not going to be able to make it today. And on the call, I have Ram. So Ram and his team are going to be presenting the pilot project that they made, that they've completed. And so we can talk about how to integrate that into DataMed. And then we have Alejandra, Claudio, Elizabeth, Huni, Nansu, Philippe, Randy, Ron, Wei. Did I leave anybody out?
Nina?
Nina, sorry. So just to go over, in terms of the agenda, we will talk briefly about action items and their updates. I also first want to bring up front the abstracts that we need to submit for the BD2K all hands meeting, and then we'll have the pilot project presentation and some discussion maybe later as to how we would like to integrate the pilot project into DataMed. And after that, we want to talk about how we would like to have more repository ingested into DataMed and how we want to coordinate between the three teams. So Jeff, George, Stephanie and I had a call, and we've kind of come up with a couple of spreadsheets that we would like to have all the three teams update as and when they do mapping and ingestion if they've started ingesting. So we'd like to talk about that. And then maybe briefly about the DataMed version 1.5 release. Earlier we talked about doing it, the release before EMEA, but I guess just today during the EC we were talking about maybe having the release done before the BD2K all hands meeting. And I think realistically speaking, that's about all we'll have time for today. For the action items, one of the action items was to generate a help and FAQ page. I checked back today, nobody has started putting in any material into the document. Now this document is available in the BioCaddy Google folder under CDT. So please add in material of the functionalities that you are familiar with, and then we can refine it and get it into a tutorial kind of or a manual format. So Claudia and Jeff are actually discussing about a robust server to host BioCaddy, and that's still an ongoing discussion. And also, we would like to get feedback from everybody with reference to the video that we demoed last time. Jeff's team has worked on that, and we would really welcome the feedback so that we can get something ready by the time, I guess, at least a more professional video by the time we go to the BD2K all hands meeting. So this is the same thing, it's in the BioCaddy CDT folder, the help and the FAQ page. So in terms of abstracts for the BD2K all hands meeting, Susanna has already submitted an abstract for that. That's already in. And the plan, the deadline is October 27th, so that's just 2 days that we have. So the plan currently is to have a DataMed abstract and submitted with, and say that we'd like to have a system demo because we want to have a hands-on session for DataMed like we did for last year's all hands meeting. And we were thinking about getting the ingestion and indexing abstract submitted also for a poster. So if anybody else has any other ideas of posters or presentations that could be submitted, that's something that we could work on in the next 2 days.
Hey, Anu, this is Ihani.
Yeah,
so
hi.
we kind of felt obliged to submit something. So Nansu and I are just trying to think of something from the data metadata mapping side because that's all we have been doing.
Okay.
But we really don't know yet. But we have 2 days, so we are trying to come up with something, but.
So once you submit, I think it asks you to pick what session you want the abstract to be considered for. There's a BioCaddy session there.
Yes, it will be the BioCaddy. No, it will be the poster.
Yeah, but even the any abstract, even if it's going to be a poster, has to go into specific sessions, I think.
Yes, that will be the BioCaddy session.
Okay, great. And once you do the submission, I think you just want to let Elizabeth know about it because she's keeping track of all BioCaddy submissions for the...
Sure, yeah. I talked to her already, but yeah.
Okay.
We just don't know yet.
Okay. Good luck then.
Thank you.
So Ram, it's all yours.
Thanks, Anu. Can I present slides from here?
Yeah.
We have an updated version. I'll send it
Okay,
to
so then you want to, you see there's a share button on top of the controls.
Yeah.
Yeah,
Can you see
awesome.
the slide?
Yeah, we see the slides now.
Okay. Thanks, everyone. We have a big team on the call. Philip Warner is online, and in the room here we have Randy Matson, Ryan Richard, Peter Moore, Dion, and Yanin. We will be presenting different sections of this presentation. This is our pilot project that we did as a part of the funding we received from BioCaddy. And our goals here are, from the presentation, is to see how this might benefit the work BioCaddy is doing and to receive some feedback in informing our next steps. So what in this project, what we were trying to see is, can we go to the next step of integrating relevant data sets from the current phase of retrieving relevant data sets? Or in other words, can we automate or semi-automate the process of data integration by some level of automated metadata discovery for data integration? So what actually led us into this project is a platform that we have called OpenFurther for data integration and federation. And most of the effort in this platform goes to discovering metadata and mapping metadata and terminology artifacts. What we wanted to see is how much can a machine or programmatic approach reduce the effort in doing this in the data integration processes. So just a little about data integration. When you have two heterogeneous data sets, we find the relatedness between those two data sets. Using the relatedness, we could then have a semantically consistent metadata-driven integration of the various data sets. So the current state of the art relies a lot on human expertise for discovering metadata, mapping the metadata and semantics, developing transformative functions, and then having a way for semantic and semantically metadata-driven integration. We did some work with the current implementation of the platform OpenFurther. One example is the FISPUS project, which had over 12,000 mapping artifacts done as a part of the data integration effort. So in this effort, what we wanted to see is, can we have a service-oriented architecture? Can we design a service-oriented architecture that can be a part of this data federation integration engine or any other engine, and what is required for such a service-oriented architecture? For that, what we developed is, what we are designing at this part is metadata and semantics discovery and mapping service, which could be automated or semi-automated depending on the uncertainty needed in the level of mapping. So we came up with various goals, and as we learned a lot more about BioCaddy itself, our goals ended up as 4 tasks. First, we wanted to catalog and benchmark existing metadata discovery and mapping methods. Second, how we could adapt BioCaddy metadata specifications into the metadata repository. Then come up with a conceptual design for a metadata discovery and mapping service. And as a part of this design framework, can we use machine learning methods for metadata discovery? So the idea was each of these 4 tasks could be independent components and at the same time be integrated. So the first part, cataloging and benchmarking, and I won't spend a lot of time into this. The main thing we found in this was many of the existing tools are not supported at this point of time and might not be readily useful for biomedical data. But some of the more recent approaches of distributed semantics and semantic indexing, some of the things which a BioCarry is doing are more useful for biomedical metadata mapping. So the next task was in adapting BioCarry metadata specifications into the OpenFurther's metadata repository. And I will let Peter Moe, our data architect, speak about this task.
Hello, everyone. My name is Peter. I'm going to give a brief introduction of the MDR and hopefully more importantly, how we can use it to adapt to the BioCarry DATS specification. So our MDR is a central repository for metadata. It can pretty much store anything that you can imagine. But some of the things that we have used in our environment is storing things like data models and associations to other data models. And also things like end user information, info button descriptions, graphical user interface descriptions, and also software modules. So, but of course you can use it to store anything that you like. So here is a conceptual view of the MDR. The main entity type is the asset in the middle. And the asset can have multiple properties, and assets can be associated to other assets. And through those associations, there can be multiple properties as well. All assets belong to a particular namespace. So the namespace is like the container to hold assets or group assets together. And optionally, you can also have resources, things like large files and URLs, etc., as resources for each asset as well. So it's a very generic and dynamic platform. And yeah, go ahead. So at our location, we have implemented this model into Oracle right now as a relational database. But the concepts of the model follow more of a graph theory design. So you could implement it into a graph database if you want to. And the metadata in the MDR can be exposed through REST API that we have into a XML format that you can consume. So some of the publication efforts that we have worked on related to the MDR include data federation and integration, and info buttons, and also data quality assessment. But these are just a few examples that we've had. There are many other publications that relate to OpenFurther that you can also review if you want to. I'm sure Ram has many of those that he can send you. So for BioCarry DATS data model, there are 3 phases that we can work through to incorporate the DAT into the MDR. The first one is to configure the DATS model into the MDR. And once we've done that, we can then configure your data sets, which are sort of your data sources. So at our site, we call it data sources or, just data sources. But I think in your case, your main focus is data sets. So, and those data sets have a data model. So phase 2 would be to configure those data models into the MDR. And lastly, the third phase would be creating association or mapping from the central model, your central model, which is the DATS model, into the dataset models. So here's an example of phase 1. The first step is, and on the right side is a small portion of the DATS model. So you have an entity type called dataset, and that could be configured as an asset, as you see in the arrow, the red arrow, into the MDR. And the attributes would also be configured as assets in the MDR as well. So those are the first two steps. So the third step is to associate the your attributes to the entity type. So for example, in your case, in the DAX environment or a model, it would be data set has attribute. Data set would have attribute the title, for example. The title, types, and creators are the attributes of data set. Of course, we would do that to all of the attributes, not just the mandatory attributes. And the has attribute itself is actually an asset as well. And after that, in step 4, for your relationship types in your model, in the DAX model, they could also become assets, and you can use it to do things like associations later on. So most of the configuration in the MDR are actually optional. And here are some more additional things you can configure into the MDR. Things like data types for your attributes, whether some attribute is nullable or not. I remember in your documentation, in the DAX documentation, there are some properties about nullable, whether they are required, must, or should, and things like that. So these things will be using the asset property table in the MDR. And as what I mentioned, there's optionally resources and relationships as well, properties for relationships. So those are optional things you can do. Here is an example of how we generate the configuration for the MDR. Currently, we're just using Microsoft Excel. And as you can see, there's insert statements and select SQL statements that are, so these statements are automatically generated using just some Excel formulas. So the Excel, we have sort of like a template where you just fill in the entity types and attributes, and it will automatically generate the SQL statements for you to configure the MDR. So for phase 2, we mentioned that that's where we configure the MDR for your data set. So things like the protein database or ClinVar. So following the similar steps in phase 1, but just for a different data model. So for integration, phase 3, to support integration, we want to associate data sets from one data set to another. And there are generally 2 strategies for doing that. The first one is using a mesh network type of strategy where you would associate every data set to every other data set. And as you can see, that would become a huge mess very quickly, and it's a lot of work to configure. So what we have done here is we have chosen the hub and spoke strategy, where we only map the external data set into the central model only once for every data set. So here's another picture of what that might look like for the data sets going into the central DAX model. So there's a maximum of two-point traversal in this configuration. So here's an example of the association for phase 3. Is the DAX model has a person entity type, I believe, and it could translate to or associate to, let's say, in the protein database, there's an author. So we can create all these mappings and associations in this phase. Also using Excel templates as tool. So potential benefits of using the MDR, mainly it's very flexible and scalable, and you can use it for just about anything and for any use case. So hopefully you folks will find it useful as well as you dive more into the details.
Thanks, Peter. So next, we wanted to give a conceptual overview of the architecture for metadata discovery and mapping. And Randy Maston and Philip Warner, who are software engineers, will present this stuff.
Thanks, Ram. This is Randy. So you can skip to the next slide there. So this is a few slides about generally how the MDR that Peter just outlined fits into the environment by which we would enable semi-automated mappings, and utilizing different tools that folks on the team have worked with. These are individual projects that currently we have a conceptual framework of how this could be a pipeline of generating semi-automated mappings to be populated into the MDR and utilize various ontology servers or terminology servers for mapping between different concepts that are resident to those models. Parts of this that we always want to build the system so that each individual component is a standalone service-oriented application, so the architecture itself fits into a SOA model. As we mentioned, we're talking about things how of the MDR ontology server, and then later on the data quality framework that we have a PhD student working on currently, of how that could actually be used to evaluate some of the like the efficacy of one of the models you wanted to use for a particular purpose, or the particular data that's resident to a model, say that's actually the content of the data. The end result of the goal is that we want to accelerate bringing in different data sources into the framework and the overall system. Right now, what we have is generally the same problem everybody else has, is that mapping is the heavy lifting, and it has to be done somewhere. And where can we interject different methods to speed that up so that we can allow the repurposing of the data for different purposes. So this is the next slide here, is a high-level workflow of how we want to be able to discover the data of a particular set. So most of these next two slides are based on the idea of using a file-based data set, but the same concept applies to whether it's a web service or highly structured data or like an RDMS or something like that. But right now what we'll use is the idea of data sets in file format. So the first step is to essentially determine what the file is. From there, we would then outline the processes of discovering the content. From there, we would actually then leverage the MDR to inform whether or not this is data that's already been characterized. This entire process is a multi-stage method for data characterization. From there, we would utilize this characterization process to actually then populate new elements into the MDR if we needed to, or reference elements that have been stored in the MDR to then move forward with utilizing that data. Much of what could be discovered and matched using some of the methods that Peter's outlined of either associations that already exist for a known file type, things like that. So these next two slides are essentially a little bit more of a granular overview of the concepts we're talking about here. So this is step one for the data set types and source discovery. There's a few main steps here. One is that we actually need to discover the file association to its content and then verify whether or not that's something that can be used. Of course, there are many steps along the way here where we can use indexing just as it's done now with tools within BioCaddy. The content itself is actually useful for being able to discover what the next steps are. So a main first step of this is actually indexing that content. From there, we could then determine at least rudimentary, at a rudimentary level, whether or not that's a file type that we already know about. And then from there, determine if there's a parser that exists. So you'll see above there there's the OFMDR, that's the OpenFurther MDR. That would be a read source and also a write source. So if there's metadata that's discovered about that, we can then store that content and then iterate over that as we go forward. Of course, there's other metadata storage sources that are available to help inform the types of content and the framework, or sorry, the file types and the types of, the outline of the data that's actually in there, so the structure of the data. Next steps there are actually then utilizing sources that we can either we've determined that we know about, something like what some of the prior work has been done with machine learning on indexing and understanding different types of data. Is it something we need to actually run through the machine learning module or not? And then from there go forward with any characterization. That's the active learning part of that. It's where we can then repurpose that machine learning to give us a score of whether or not this is a known data source or not, and then begin to store new data about it. From there, we can have at least a reasonable guess at a known file type, and then be able to move forward with the next step. So now that we know the structure of the content, we can actually deal with some of the content characterization. Once we know the content structure, we can essentially just loop through every part of the file. What we're really trying to do is match those different types of parts of the file. Now that we structurally can decompose the file as assets. That's the bottom line, is that those assets then become something that we store metadata about. And you'll look over there on the right of this workflow. Every part of this essentially points to something about storing metadata about every one of those elements that's been discovered. It's just a looped process from there on out. And of course, there are different parts where we can interject either natural language processing or parallel processing of the data to then match against different assets or known assets in the MDR. And that can be, that work needs to be explored. This part of it is just a conceptual overview. So that's the essentially a quick concept outline of what the overall view would be of a metadata management service, and whether or not it's a known XML or a structured file type, where we have different kinds of techniques that are already available to determine the data, or if it's a flat file of structure that's unknown. That essentially is then pushing you into the metadata discovery process, which then you can, depending on whether it's the structure of the data or it's the content of the data, utilize various mappers and tools that a human can either interject with, or you can, depending, as Ram mentioned, if you have an acceptable level of uncertainty of the data, it can be almost fully automated. From then, if you do have something that has to have expert review, you can review those mappings at the source level for the structure of the content, and then, of course, at the content level. But the content level gets extremely deep. That's where the terminology server, the metadata repository, and the quality analytics framework become essentially they're symbiotic parts of the entire process, where each one of those creates the knowledge about what those assets mean, and from there you can actually then produce more specific knowledge outputs for each type of data set, of which that would be the learning module. That then can be utilized once you have a fully characterized data set. There's different workflow platforms that we've also been exploring on what is it that we can do to orchestrate all these different moving parts. There's the Swift language, not to be confused with the Swift programming language from Apple, but there's that's more of a programmatic HPC environment language, but could certainly be utilized for orchestrating different processing parts of the framework. Galaxy could be used for when you actually have data sets that have been characterized or transformed to then enter into a pipeline. And of course, you have Apache Taverna, which is more of a workflow tool, and Pegasus, which also is a workflow tool, but more in an HPC environment. All of these could actually be integrated into some kind of pipeline where the automated services of characterization of the data set can then lead to transformation of the data set depending on how the assets for each data set can be reused, such as if you had something from a protein DB data set that you need to extract a certain portion from to then populate it into a model where you have patient data. That's the ultimate goal, of which each part of this has been explored in various ways, but the overall framework needs to be implemented in a larger research project.
Thanks, Randy. Do we have time or should we end?
So we have 20 more minutes. I think do you think you would be done in about 10 more minutes?
Yes,
so
sure.
We have some time for questions?
Yeah. So the last part is our work on machine learning methods for metadata discovery, and we'll have Jingran Wayne present on it. Jingran is a postdoc in the biomedical informatics department.
Hi, I'm Jian. I'm in the next field, but maybe I will walk you through quickly how our machine learning approach is designed to meet the goal to automatically identify data sources and data types. So as a lot of biomedical data set is stored in the text document format, so at this point, our machine learning approach is mainly focused on processing the text document. But the text document can be in any format, like the plain text, XML format, or HTML format. So all of these file types and formats can be processed through the same interface as shown in these workflows. So it is very simple. First, the file is tokenized into the tokens or words, symbols, or other meaningful elements using any of the tokenization modules. Here we use the NLTK tokenization modules. And then all those tokens in the document is processed through a homegrown document processing module to extract the token frequency features and token structure features. And these structure features is used as input for our machine learning approach to build the document type classifiers. And after we have the classifiers, all the parameters of the classifiers plus the features of the of each type of the document will be stored in our document type knowledge base, that is MDR, and which will be used in the future to automatically identify the data types and data sources. So the example structure and the content features can be used listed here include the token frequency, token structure features such as the length of the tokens, the proportion of the capitalized words, or the proportion of the numerical values. In the meantime, can include any other features like the types of the punctuation. So we did some preliminary studies, and in our preliminary results, we included about medical data from various sources and in different file formats, include the protein structure data, genetic variance data, scientific papers, and also the general English corpus. For the protein structures, for each type of the data types, we included different data sources in different formats. For example, for the protein structures, we included the ISA, PDB data, protein structure data in PDB format, CIF format, and XML format. And in the same time, we also included the predicted protein structures that is generated in our own lab. In addition to the training data set, we also include external data set, tester set, that is totally have no overlap with our training data set. So with the features and data set, we trained several of the machine learning models, and we use both the tenfold cross validations and the external tests for our evaluation. So this shows the preliminary result of our decision tree models. So from this result, it shows that our decision tree model did a very good job distinguishing the different types. So for the tenfold cross validation, our decision tree models was able to have the F1 scores to distinguish protein structures, genetic variants, scientific papers, and general English corpus with the F1 scores all above the 0.888. And when with the external tester set, our model results in comparable scores to those of the cross validation with F1 scores of 1.0, 0.99, 0.98, and 0.93 for distinguish the protein structures, genetic variants, scientific papers, and general English corpus.
Thanks, Jingyon. So some of our next steps are on extending the machine learning framework for environmental and clinical data, and also include an uncertainty component. Publish our results from the forecast. We are working on the workflow platforms to see how we can use the conceptual workflow in one or more of these platforms, and we're looking forward in using this work for continuing it through either collaborations with BioCaddy, NIH, BD2K, and also look at other RFAs. So that's what we have. We have a large team. Have some places for all of us here. Thanks. And if you have any questions, we're open to questions now.
Thanks. Very nice talk. Any questions?
Hi, Ram. I have a question. So in order to use the system, do we have to map that to your MDR model?
Okay, can you repeat the question?
Sorry. So my question is, to use your system, do we have to map that to the MDR model? Because mapping is time-consuming.
So the MDR model is more a very high-level entity relational model. Everything is an asset, and there are associations between assets. So in that sense, the only thing that you would have to map to is create assets and associations between the assets. So every entity and attribute in an existing model, let's say that specification would end up being either an entity asset or an attribute asset, and mappings between the entities and attributes will be associations. So that's the only mapping that would have to happen. There isn't any other specific mapping. The metadata, the MDR, the metadata repository doesn't have any other, I would say, semantically heavy model. And what else?
Is she asking about the mappings to the data sets or?
To the MDR, for using the MDR.
Generally, this is Randy. Generally, the answer is an MDR has to be used at some level. So whether or not it's the one we have currently implemented or a different service that actually provides a repository for metadata artifacts, there has to be 3 levels of things. One is that the assets are recorded in a generalized way, and then the associations between either a target model and a source model need to be recorded as well, so that you can then enact some sort of translation. So the basic functionality is that an MDR exists, and we leverage that MDR with other semantic systems like a terminology server to then translate from one source to the other. In the case of BioCaddy, it would be more of a reference tool to then know whether or not semantically one source has an association with another. So it could be this MDR or it could be another, but basic functionality needs to exist in that way.
Well, in terms of BioCaddy, another way that you could see it is that it actually is a conversion, right, between whatever's coming in, to, the more sort of high-level or structured DAPS format, right? So that could be your source and your target, and you could, potentially learn that. And so, one of the questions is now that we have, we're getting more and more mappings. The question is how would one, is there, we already have sort of mapping statements, so I'm just wondering how easy it might be, to ingest, mapping statements that we have that say, this element, translates to this DATS element.
Well, the short answer I think would be it sounds like it would be pretty straightforward. I guess it's a matter of how it's implemented in a particular system for what our desired outcome is for translation, right? So if we want to then reuse our implementation we already have, then we'd have to transform the current mappings that already exist, and I think that would be pretty straightforward. Or I think the better option would be to actually just be able to consume as a resource the mappings that already exist in DATS in association with either lightweight assets that are available in the MDR or as a sole source.
So in terms of work, it would be loading the mapping as associations and entities and attributes as assets in the spreadsheet that Peter showed screenshots of. We have a complete spreadsheet of all the map assets and associations of the DATS version 1.0 available for loading into the MDR, which could be implemented as a graph or a relational database. So every other source could be a similar spreadsheet that can be loaded. I think comparatively straightforward. It should not be that difficult.
So I have a quick question. How much effort would it take to update models then? Like you have it in DATS 1.0, but the current version of DATS is 2.1. And if you have to update the model, and the 2.1 DATS is more extensive than 1.0 was.
May I? What we have found with our data models here is that whenever there's a major version upgrade like this from, say, 1 to 2, it's actually much more efficient and useful to create a new namespace for the newer version, for the new major version. And then we'll just reconfigure the entire new version into the MDR. Part of the reason is because sometimes we still want to reference the old version, and therefore we want to usually keep both versions into the MDR. Does that answer your questions?
So in addition to that, I think you can also create relationships, or in our word, associations between the version 1.0 and 2.0. So you can have version controlling and take all your mappings that were there to 1.0 to 2.0 by using the relationships between 1.0 and 2.0.
So then if something was already mapped to 1.0 and you draw a relationship to 2.1, then you would have you wouldn't necessarily have to remap those repositories to 2.1, right? That should get done automatically.
Yes. If they are straight mapping, and if the semantic granularity has changed, I mean, if between an entity in 1.0 and 2.0, then yes, we have to redo the mapping. But if the semantic granularity remains the same, then they would automatically map from 1 to 2.
So I have a question. So I was wondering how if you have a library of mapping methods and then you apply the mapping, how do you evaluate, and especially in the discussion about updating to a new version, how do you evaluate that the new mapping is correct?
Human evaluation. So you have
currently it's a human effort, but part of the goal is to automate.
Yeah, so part of the goal is to automate and see how we can automate, but at this time the gold standard is the human.
The secondary part of that is to actually utilize the data quality framework. So there may be some, as Ram mentioned, some sort of semantic granularity mismatch between one version and the other. There are different parts of data quality measures that could be applied to see whether or not translations change from one model to the next or data set to the next. Of course, that's fairly intensive, but at least if you had a set that you're confident with, that could be automated. But the bottom line is that most of that is going to be a gold standard of human review.
Okay, thanks.
Are there any other questions?
So you use the machine learning method to classify the data type. So what's the data type here?
So the machine learning method was used more to discover file types. And so between PDBs,
genetic variants, scientific papers.
Yeah, so it just brought up the slide. So PDB files, genetic variants files, scientific paper, literature, and general English corpus.
Okay. Thank you.
So do you have some kind of a data type ontology available?
So we have the a data set ontology for classifying different data sets.
No, I see that you primarily doing it based on the file types, right?
That is right.
But I also see a column which says data type where you have protein structure, genetic variants, scientific paper, and I was just wondering if you've got an ontology for data types available or not.
No, we don't have an ontology for data types. In this slide, so for example, the PDB file, we use 3 different file types: the PDB file, the CIF file, and XML version of PDB.
Yeah, so what we use for the machine learning thing is only the intrinsic structure features of each of types of the files. So at this point, we didn't include any ontologies for the training of our machine learning models.
Yes, I think that's a next step on using existing or developing an ontology of file types that will fit into the workflow in deciding what metadata and parser to use to parse the file and then map or characterize the content of the file.
So are there anything else? So if not, thanks Ram, and thanks everybody on the team. slides. Let's see if I can get to it. So we very briefly want to talk about what the 3 different teams are doing for the metadata mapping, as well as what we would like each of the teams to actually plug in into these 2 spreadsheets, so that we can follow which of the repositories each team is working on. So one of the things is this particular spreadsheet, which is available in the BioCaddy folder under the CDT version 1.5, DataMed version 1.5, is where we want everybody to actually, as and when you're mapping the different repositories, we would like to have these mappings actually kind of followed through here, where you're looking at the 2 metadata fields from the repository, as well as the DATS model, and just putting it in as you're mapping, and also to let us know the status of your mapping, whether the sample data was generated, the transformation has been done, and the transformation has been set. That would enable us to follow through and figure out where we are in the ingestion step and in that pipeline. So if a repository that you are working on is not available, why this is so slow, is not available, please add in the repository and enter in all the mappings here. So Jeff's team and the UT Health team have been putting them in. Huni and Nansu, can I ask you guys to ensure that you enter all the data in here, so that we have an idea of where you are at with your mappings? This will also serve as a place where Burak can go in and let us know exactly where he's at with generating the sample data, and to figure out if the transformation has been checked or not. And once the transformations have been checked, then he can go ahead and ingest this metadata and index it.
Okay.
If you want, I can send the link again to you for this spreadsheet.
I think we already have the link.
Oh, okay. So the other spreadsheet that we have been primarily looking at, and this is to get a high-level overview of where the 3 teams are with reference to mapping. What we decided to do was one of the things that's probably going to get implemented but has not yet been implemented is to have a priority score that's still being discussed. George is actually had come up with a way to calculate priority score, and once it is cleared by the executive committee, we can implement it. So that way we will know, based on the priority score, we will know what the high priority repositories are for mapping, as well as for ingesting and mapping. But what is probably going to be relatively new is we want to also track the date that the ingestion was started, and we want to figure out the dates when we actually had, this is to get an idea of how long it takes to ingest a specific repository. So if we could have this entered in, the date that the ingestion was started, the date the metadata mapping was completed, and the date that the ingestion was completed. Then After that, I can pull in the indexing, completed indexing date and other details from the other spreadsheet to populate this spreadsheet. So ultimately, this will be the spreadsheet which gives us an overall view of where we are in terms of each of the repositories that we are working with. And if there are specific comments, say for example a repository site is down, or you're in contact with the repository and you're waiting for a reply from a specific repository. I think some of them, like for example SimTK that Shaolin has been working with, they said that they have some issues with their services, and so they would have to fix it. It will take a couple of weeks, and they'll get back to us in a couple of weeks. So they've asked us to check back with them in a couple of weeks. So such comments could be written in here, so that everybody who looks at the spreadsheet gets an immediate idea of where we are with each repository. And if anybody has questions with regards to the repository, then they can look at this and say, hey, okay, this is where we are and this is what this team is doing. So these are the two main spreadsheets that we will be working with to kind of track the ingestion process. Are there any questions or any suggestions as to how we could maybe make this more efficient? And if you don't have links to any of these spreadsheets, please let me know and I can resend the links to everybody again.
One question: is it right that there in the spreadsheet there is no link to the transformation file? Maybe that would be helpful.
Ah. You mean here or in this one? Maybe here, right?
Yeah, maybe that one that is more specific. I don't know. I mean, it could be helpful, but.
Okay. I think that can be easily done. Thanks, Alejandro.
Yeah, I mean, they're all in the same. All the final transformation should be in that BioCAD data pipeline repository. So.
I can just add in one column here, Jeff, and we can have links to each of the individual transformations.
Yep. Yes, it would be one row so that each of the repositories would have its own. I mean, I think it could be helpful if from here that you are seeing the detail, you can go straight into the transformation file, but it's just a...
That's correct. I think that makes sense. We can add that. So is there anything else that maybe we could add in to make this more useful?
Yeah, for the notes, I'm wondering, can we cross-link sheets in Google? That's we need to look at that, because on the other status sheet, there's also some notes and comments. So it might be
update automatically, you mean?
Yeah, so that we only have to fill it out in one place.
Right. So I was also thinking here where you have the checkboxes, right? Is there some way of actually having the dates in? Because if you are going to cross-link it, then we might have this populating automatically there. If they fill in the dates in this spreadsheet, it can then get populated on the other spreadsheet, right?
Well, the dates, yeah, I mean, because the dates below that, you mean the dates below the checkboxes, right? The ones,
right.
The beginning.
Yeah.
Yeah. Potentially, yes. So we'll just have to, I guess I'll have to Google Sheets to see if we can cross-link.
Okay, so maybe I can also try and look into that, and then we can kind of make it a little easier so people need to enter it in only one spot.
Right.
All right.
When Alejandro Felipe says hi.
Okay, thanks.
He's in the same. I saw him. I didn't realize he was going to be out for this meeting. So.
Okay. So are there any questions with regard to this? The other thing that I want to talk briefly about, I know we are already like 8 minutes over time, but we would like to have a data med release before the BD2K all hands meeting. This would be version 1.5. So we'll have approximately, I think, about 40 reports that would be mapped to that 2.1 by that time, hopefully. And we would have some of the additional functions that we've been talking about. And before release, though, we do need this to be tested. So the BD2K all hands meeting is on 29th is the BD2K. So maybe we should target the release for 28th. So my question is, we need the testing could be done November 20th. Is that early enough?
24th is the Thanksgiving
weekend, yeah.
Yeah.
Not 24th.
Yeah, 24th is the Thanksgiving.
So this November 20th is the Friday. So we won't have a lot of time. We'll just have 4 days. So would November 17th work? That
Anu, just to be clear, for those not in the U.S. who may not be aware that November 24th is the Thanksgiving holiday. So the 24th, 25th are probably going to be times when people are not going to be at their computers. So doing it perhaps by the 18th, completing it by the 18th, might give enough time.
Doing testing by 18th?
Yes, that's a Friday.
Yeah, so is that enough time if there are things for you to fix, bugs and other things? Yeah, but none of them are going for EMEA. Only Ergin and I will be gone for EMEA. I think we should be able, at least I should be able to work from there. So how about 17th then? Because it took us a day last time to test, right? So that will give like 18th, 19th. Oh, okay. 18th, 20th, 22nd.
Yes, 23.
And 23rd. 4 days for fixing everything and making sure it's working okay. And then 28th could be the release then.
I'm off that day. And you will go to the...
Right, but we leave in the afternoon, right? Mm-hmm. So can we do it in the morning or?
Maybe we can try to release on
23rd?
Yeah, 23rd, yes.
Okay. But if you want to release on 23rd, do you want to have the testing? So Jeff, do you think you will have people who can test like you did last time?
Yeah, I should, yeah.
So should I contact you, Ling, then?
Yep.
Okay. And Huni, on your side, would you have some folks that can test? Okay. I do not.
I think we can find something.
Okay. So then I'll contact you, Nansu or Huni, and then to talk about the testing. But basically, then we'll say we'll test on the 17th.
I can ask if Ian would be interested in doing some testing as well.
Okay. I can actually put you on, because what we do is we typically have at least 2 people testing each function, and we try to have them test on different systems and coming from different places.
We'd be happy to participate.
Okay, that would be great. So can I add you and Ian then in the list?
Yes, why don't you go ahead and do that?
Okay. Okay, that's it then. That's pretty much all I wanted to talk about. So just before I leave for EMEA, I guess I'll set everything up and send it out to everybody, and we'll test on the 17th. So was there anything else that we needed to talk about before we are done with this meeting?
Actually, I have some questions about the source code shared with us 2 days ago by the Brock. So actually, is that means that we should run over the pipeline with the source code and generate the Elasticsearch to import to the system? I mean, before what we did is like we just take care of the sample data and transformation scripts. But now since we have the pipeline, so I don't know whether we should go through the pipeline, generate the index directly.
Well, you can. If you have it running independently, that allows you to do the full sort of end-to-end testing, and having the Elasticsearch documents. You can give them to Ling at that point, but we still need to get then, your source configuration and transformation into the production system, when we then rerun things, right? So this makes it easier, for you to test things locally, and you don't have to, you can just test and curate locally.
Right.
But we still need to
Since now the repository has different metadata and different extraction methods, so we have to rewrite some functions in the source code. So which means that we have to update the source code with you guys, right?
Yeah, because some of the, for example, when we add, for example, the publication enhancer, then you'd have to update your source code for that.
Right.
I think the only enhancer that you guys don't have is the plugin for the NLP enhancer, but that's being worked on right now.
Okay.
And then we just have to make sure that the workflow that you define for the data processing, data processing is the same.
Okay. So in terms of the repository already assigned to us, what do we have to deliver is it's just the sample data and the transformation script. Is that right?
Well, no. Well, to get the sample data, you need to have a configuration for that source.
Right. We are working on that now. Yeah. We're working on that. Yeah. Okay. Thank you.
Okay. Are there any other questions? If not, then thank you all for coming into the meeting, and my apologies for it running over.
Thank you.
Bye all.
Bye now.
Bye.
Thank you. Bye.
Thank you. Please stand by.